Stellar Energy by me, Julissa Livingstone. To the left, there is a table, a diagram, and a graph that each explain the solar radiation coming to Earth. The table, graph, and diagram each have their own explanation. The diagram is a representation of parallel angles of light coming towards Earth. The table is recorded data of the diagram representing the solar radiation coming to Earth, while the graph is also another data source shown into comparison. Out of the 6 stations that were completed, the station that involved the solar panel to be tilted at different angles shows the effect of solar radiation to the Earth. The Earth has a circular round surface, making the other places around the world not to receive the same amount of light energy from the sun. With different amounts of solar radiation in different areas, the time of day is different and the sun shines either more or not as much. This is represented in the diagram above. In the figure above, the star HR 8799 and our sun show the amount of ultraviolet, visible, and infrared energy within them. From the figure to the left, I think that the star HR 8799 emits more energy from our sun. As you can see, HR 8799 has a higher intensity with the ultraviolet light energy. This light energy is dangerous for the intensity to be at such a high number, but that's not all. Not only is ultraviolet a factor, but visible and infrared energy are stronger in the star than the sun. Although the sun is powerful, the star HR 8799 tends to emit more energy. Each of the stars are different in their own way, as you can see from the star HR 8799 and the sun. The differences between them are shown in the figure above. Our sun and the star HR 8799 have certain energy peaks for the curves and the 3 light energies. With ultraviolet, visible, and infrared, HR 8799's peak is in the ultraviolet light, while on the other hand, our sun's energy peak is in the visible light energy if you look closely. For the star HR 8799, the 3 light energies have their own job. However, the ultraviolet light energy is most likely to give off a sunburn from the star because it is the main intense factor within it. With the ultraviolet light being intense in the figure above, it would most likely cause a sunburn. In previous readings, it says UV light is damaging to the cells in your body. Damaging is caused by a sunburn on your skin. Therefore, I could get a sunburn from the star HR 8799. Concept learning. In the diagram above, it made me realize and learn several things. First off, Earth's orbit around the sun made me understand the reasons why we have 4 seasons: spring, summer, fall, and winter. But also, it taught me that the Earth doesn't receive the same amount of sunlight around the world at the same time. This is also presented in the diagrams to the right. There's 1 and there's 2. Within this chapter and concept, I learned most of my information surprisingly in figures and models. As Earth orbits the sun, winter occurs when the Earth is the farthest away from the sun. You can tell when Earth is farthest away from the sun by the arrows. Even though it is not listed in the readings, another factor is tilt, which is shown on the diagram. The factor tilt results in changes in heating that lead to seasons. You can tell how we have 4 seasons by just looking at the Earth's orbit. Every 3 months, March, June, September, and December, the sun gives off sunlight to a different part of the world. With the months March 21st, June 21st, September 21st, and December 21st, those are the dates of each season. March 21st is the first day of spring, June 21st is the first day of summer, September 21st is the first day of fall, and December 21st is the first day of winter. With that said, I am able to tell why winter occurs when the Earth is the farthest away from the sun.